students who have the flu. A lot of flu out there. Hot-blooded. Got a fever of 103. That's foreigner. We'll go back to that. What I want to do is, this is going to be another lecture. This is going to be a lecture, we'll call it lecture 3. We'll call it fluids, scientific notation, lecture 3. Okay? Lecture 2 was a lecture I did with a PowerPoint and still shots. So you should look at that. This is going to be a little bit of practice and some more of a visualization on what to do and a little bit better explanation. So what I want to do is you need a calculator like this. You need a calculator, graphic calculator. And I'm going to put a problem on the board right now, and I want you to do it on your calculator and see what you get. Okay? We'll start with a simple one. 4.36 times 10 to the negative 6th times 8.2 times 10 to the 4th. Okay? Do that on your calculator. You know, if you didn't see lecture 2, then stop this tape and go back and look at lecture 2. But if you have seen it or you're familiar with scientific notation, then try this. I'll be right there. Okay, so if you plug it into your calculator, we could do it that way. Let's do it 2 ways. I'm going to show you how easy this is. Right. What I did was, you plug it in. These are the buttons you press in this order. 4.36 times second EE negative. That's down in the lower right-hand corner. That's the negative right there. See that? Okay. And 6. And then times 8.2 second. Not very neat. 2, then second, then 4, then equals. Okay? So if you didn't do that, try that. I'll plug it in myself. So 4.36 times, sorry, that's not what I wanted to do. Second, EE negative 6 times 8.2 second EE 4. So that's what I have. That's what I have. And that's what's going to show up on your calculator. And then when you hit enter, you'll get, you know, if it's small enough, they'll take it out of scientific notation. So the answer is 0.35752. Now that would be incorrect to put that. See, I have 3 significant figures times 2, so I can only have 2 in my answer. Okay? So it's going to be 0.36. Okay? That's the answer, 0.36. So you have to round it. So you don't have to use scientific notation, but you have to be able to use it if they give you a number in scientific notation, and it's a really large number, you know, you have to be able to work with it. You know, you could put 3.6 times 10 to the negative 1 if you want. Doesn't matter. Scientific notation is to be used as a convenience, not as a burden. It shouldn't make things harder. It should make things easier. So that's your problem. All right, now let's do another one. let's say we have the same problem. Let's say we have the same problem. Now, I'm going to do it a different way. I'm going to say this times this. Okay? All right, now, what that is going to be 4.36 times 8.2, two significant figures. I get 35.752, which is 36, right? Times 10 to the, that's negative 6 plus 4, that's negative 2. And then it's simply the same. 0.36 equals 36 times 10 to the negative 2. Same thing. Now this is not strictly scientific notation. I don't care. What I care is that you get it mathematically correct and that you don't abuse significant figures. If you said 35.8, I don't care. But if you have too many significant figures, it gets really ugly and it's a pain for you, it's a pain for everybody. So, you know, when in doubt, just use 2 or 3 significant figures. That's fine for the work we're doing. So this is okay, it's fine. But if you want to put in scientific notation, and I'm going to move this way, that has to decrease or increase by -1. So it'd be 3.6 times 10 to the negative 1, which is what we said, or simply 0.36, same thing. Okay? So you can do it. You can do scientific notation problems without a graphing calculator. You can do it without a scientific calculator. You just need a regular, you know, add, subtract, multiply, and divide. When I first started teaching, the kids used very basic calculators that could only do the 4 basic operations: addition, subtraction, multiplication, division. So they would multiply those 2 and then use scientific notation to do the rest of it. But the graphing calculators made things so easy. But are you responsible for the more involved? No. Get the right answer and know what's going on. You don't want to be ignorant to the process, although you want to make the process simple. Concentrate on the physics and let the math be controlled by basic equations and your calculator. Let's do another one. Let's do one that's a little bit more involved, okay? Let's do one that's a little more involved. So 4 times 10 to the negative 8th times 6.0 times 10 to the negative 4 divided by 8.64 times 10 to the negative 4 times 9.34 times 10 to the 6th. We'll say negative 6. Okay? Easy? Okay? Now, remember when I said that when you put something in a calculator, it's automatically parenthetical? That's true. If you put in the calculator, if you put in 4 times 10, you know, second EE negative 8, if I put that in, right? That's 4 times 10 to the negative 8. That's automatically parenthetical, right? And then you'd say times this. 6 second EE negative 6.0 times 10 to the, you don't have to put in the 0, times 10 to the negative 4th, right? So I'll come around. So that's what you have. Can you see that? I don't know if you can see that. Yeah? That's what you have. But then when I divide, then I have to use parentheses because I'm using 2 parenthetical quantities. So what you have to do is when you say divided by Then you use parentheses. Okay? I don't know if you can see that. Can you see that? Okay. I'll show you in a second. 8.64 second negative 4 times 9.34 negative 6 close parentheses. Okay, let's see if I can show you this. Okay, so you can see, can you see that? See what I did? I put parentheses there. The parentheses are right there. That's parentheses. 8.64 negative 4 times 9.34 negative 6. Okay? And then close parentheses. Equals. See that? 0.0297. See that as your answer? Okay? So that's going to be, you could say it this way. You could say 1 centimeter figure. It's easy. So you're going to say 3 times 10 to the negative 3, or 0.003. Either way, you can say that. I'll come around. So you're rounding to 1 centimeter figure. Okay? You're rounding to 3. 9 rounds 2 to 3. So it's 0.003. Or 3 times 10 to the negative 3. Either way. Now let's do it the old-fashioned way. All right, see if we can do that. So just go 4 times 6 divided by parentheses 8.64 times 9.34 close parentheses. So you're going to go 4 times 6 divided by parentheses 8.64 times, no, sorry, 8.64 times 9.34 close parentheses equals 0.297. 0.297, which equals 0.3, right? 0.3. This is going to be negative 8, negative 4 is negative 12. That'll be 10 to the negative 12th. This will be negative 4 and negative 6 is negative 10. So negative 12 minus a minus 10. I'm going to erase some of this. So this is going to be 10 to the minus 12 minus a negative 10 will equal 10 to the negative 2. And you had the 0.3. So you had 0.3 times 10 to the negative 2, which is exactly what we said it was. We said this. So if you move this over here, that turns into a negative 3, or simply rewrite it. All it is playing around with decimal places, significant figures. It's not a big deal. If you want to put, 2.297 times 10 to the negative 2, or 0.00297, that's fine. But you don't need to. Don't make it harder on yourself. Make it easier on yourself. That's what these rules are for. These rules are not to make your life miserable. Believe it or not, they're to help you. Okay? I think I might be running out of juice, so I'm gonna quit and come back for part 2 of lecture 3. Okay? Or part B, we'll call it. So I will stop this. Let's listen to a little Foreigner, shall we? Hot-blooded. And I'll come back with another Foreigner song that is very seasonal, very appropriate, okay? Oops.